Hi, hello, dear students. Welcome to my speed practice or race academy's chemistry NEET questions discussion before the examination. Organic chemistry part I will take. I will discuss the questions. Damn sure questions I will discuss. Okay. In this video, I would like to give a clarity on what are the most expected topics questions from organic chemistry. I will discuss. It is a part wise I will discuss. Video to video I will release. So step by step. In one video I will discuss some questions. Next video it will be continued like that. A series of that videos I will post up to the examination. Okay. Let us start. We have a question is present like this. Okay. On seeing the question, you can understand that it is IUPAC name of the compound question. IUPAC name of the compound. Which they have discussed. On seeing the ring, you will come to know that one conclusion. It is little complicated, but it is type of questions they are going to definitely discuss in this coming exam. As the competition is high, then we have to prepare this type of questions. So seeing this structure and all, understanding one point, the naming nomenclature of this one is starts from this double bond onwards. So C2H5 is present on first carbon, and fourth carbon we have a side chain is there. Side chain name is actually 5 carbons is the parent chain. 1 and 4 we have methyl groups are there. That is 1 for dimethyl pentyl cyclohex 1N. So 1 ethyl 4 1, 4 dimethyl pentyl cyclohex 1N is the name of this compound. In this, if you would like to know about how that one came, I'll show it to you. Actually, they have given the structure like this. Here ethyl is there. Here one double bond. In this position, we have CH, CH2, CH2, CH, CH3. 2 times is present. Here one more. Here we have CH3 is present. So in this particular case, what you will do is, you will start the numbering differently. Start the numbering differently. That how is that? But this is the first one. This is the fourth one for the ring. So cyclohexane is the ring. On the first one, we have ethyl is there. When it comes to the separate nomenclature for this, whatever the side chain is there, the separate nomenclature, if you carefully see, then in this one, we have, this is the first carbon, second one, third one, fourth one. Yes, you can consider any one is fifth one. This is fifth one. So on the fourth one, we have one methyl. On the first one, we have one methyl is there. In such a case, you can write this one as one ethyl 4. On fourth carbon, the side chain is there. That side chain nomenclature is 1, 4 dimethyl pentyl. So what is pentyl is the side chain name. The side chain name that is there in on fourth position of cyclohexane. And first carbon we have ene is there, cyclohexene or cyclohex-1-ene. That is the correct name of that compound. Okay. So now you can observe what is the exact structure given to you. Is the structure given to you, and correct name of the correct for structure of the option of this one is second option is the right option for this question. Let us see the second question. See, carefully observe. The question is, which of the following molecules all the effects index to Mesoamerican hyperconjugation will get operated? So in this one, if you just carefully observe, first option we have chlorobenzene, inductive effect is possible. Second option we have a double bond is there, although that is not going to get delocalization. Whereas third option we have ketone directly linked with a double bond unsaturated carbon. The chances are very high for this mesomeric as well as hyperconjugation. So that hydrogen attached to an sp3 carbon in turn linked with an sp2 carbon is hyperconjugation. So mesomeric effect also possibility is there. The third option we have. So what is that? Once again, we will check it. That is structure, how the structure is there. We have a ring structure is there, they have provided. And that one you can carefully write it as here CH3. And one side we have COCH3 is there. COCH3 is present like this. So in this, we have inductive effect is possible, positive inductive effect. And also we have resonance effect or mesomeric effect is possible. Same time, hyperconjugation also possible. Hyperconjugative is also possible. Okay, that is the correct option for this question. So correct option for this question is the second option. Third question. The acidity order of the following protons in each of the following is. There are three Romans they are given. And carefully observe, we have the groups attached to that middle, that is a 5-membered ring or one hydrogen, one other group which is showing some electronic effects. You just carefully observe in this one, what we understand here is nothing but NO2 group, obviously it exerts negative resonance effect with this type of conjugations, and CH3 group in the third Roman given is exhibiting positive inductive effect, whereas NM3 trimethyl amine, whatever shown here, Me3 plus charge is there, that shows negative inductive effect. So because of this, what we understand is NO2 group where it is present, that will be obviously that will have such type of acidity. Okay, and minus R effect is shown, whereas CH3 group and Me3 groups are there. These groups are said to be changing their entire acidity, lesser acidity. So NO2, wherever it is NO2 is present, that is a greater acidic character, and Me3 is there, that is lesser, and least one is CH3 attached ring is there. So that's the option. So here what we need to understand in this question is, we need to understand few things, that Me3, so 3 times that methyl group is there on that nitrogen, 3 times, and that actually shows Yes, minus I effect. Whereas NO2 group is there, that NO2 group exerts negative R effect. Whereas CH3 group is there on the 5-membered ring shown, that exhibits a positive inductive effect. So when NO2 is there, that is greater in acidic nature. Acidity is greater. So negative inductive effect, positive inductive, least, that means least acidity can be observed when we have CH3 group is present. So accordingly, if you think, then what might be the right option for this one is nothing but second one greater than first one greater than third one. So C option is the right option for this third question. Let's see the fourth question. What is the first question is dipole moment of vinyl chloride is lower than that of ethyl chloride. What is the reason behind that one? So whenever this type of question discussed, dipole moment of vinyl chloride is lower than that of ethyl chloride, the told means vinyl chloride we have a double bond is there, ethyl chloride we don't have such type of double bonds. That's why because of some resonance effect, the vinyl chloride is exhibiting such type of lower dipole moments than ethyl chloride. So we will see that structure of vinyl chloride once to get a clarity on this. We have vinyl is CH2 double bond CHCl, where chlorine is having lone pairs on it for the delocalization. So lone pairs will come on the chlorine like this onto the sigma bond, and the pi electrons, pi bond is shifted towards the carbon. Then one resonating structure we can write, that is CH2 will become minus single bond CH double bond Cl. That chlorine will get a positive charge after the shift of the electrons. So this type of resonance structures are possible because of this dipole moment is said to be lower in case of the vinyl chloride, whereas compared to ethyl chloride. What is ethyl chloride is CH3, CH2Cl. So such type of chance is not there, resonance in the ethyl chloride. So ethyl chloride is having a greater dipole moment than vinyl chloride. Okay. So what is the right answer is first option is the right option for this question. Dipole moment of vinyl chloride is lower than that ethyl chloride. This is due to resonance effect. Next, fourth question. The hyperconjugative stabilities of tertiary butyl cation and 2-butene respectively are due to tertiary butyl cation is stable and 2-butene is stable. So they are stable because of what kind of the following conditions. If you carefully observe sigma p, so sigma and p empty orbital, sigma pi star electrons delocalization given in the first option. It means this tertiary butyl cation is having the sigma bond and empty p orbitals. So their delocalization is making tertiary butyl cation is stable. Whereas sigma and pi star electron delocalization in case of this 2-butene alkenes is observed. So that's why first option is the right option for this question number 5. So the hyperconjugated stabilities of tertiary butyl cation and 2-butene respectively are due to the no bond resonance of sigma and p empty p orbital, no bond resonance of sigma and pi star electrons delocalizations. Next, question number 6. Arrange the carbon ions. So we have 3 types of carbon ions are given. 4 types. Trimethyl carbon ion means tertiary butyl carbon ion, trichlorocarbon ion, and secondary carbon ion, phenyl benzyl carbon ion. So these are the things given. In this, we need to identify the correct option of order of decreasing stability of their order. So on seeing this one thing is clear. The negative charge is going to be a little bit reduced because of halogens attached to negative carbon. So trichlorocarbon definitely will be such type of thing. Whereas benzene ring is also one of the electron density species that always tries to take the electrons from the groups attached. So a benzyl carbon ion also will come next to that. After that, secondary, after that, tertiary will come. So third option is the right option for this question number 6. Arrange the carbon ions in decreasing order of stability. Means that tertiary butyl carbon ion or trimethyl carbon ion is one of the unstable carbon ions. So more is the density is developing on the negative carbon, is lesser is the stability, is the meaning of this CH3 thrice C minus is an example. So C option is the right option for this question number 6. Let's move on to question number 7. Consider the following reactions. We have 3 Romans are there, conversions they are given. In these 3 conversions, yes, first Roman they are given one unsaturated carboxylic acid into the alkene. Second one they are given one carboxylic acid and ketone functional groups. Finally, carboxylic acid has got removed. Third one, they have given that tricarboxylic acid converted to single monocarboxylic acid. In which of the cases the parent compound loses its functional group in preference. So according to which preference these all parent compounds are losing their functional groups. Means in every equation we have loss of one functional group is observed. That is nothing but carboxylic acid functional group is observed. That how in which preferential order the Roman number of the equation Roman number should be arranged to get a clarity on this. Means parent compound losses functional group in which preference. The question is which preference. See the first Roman. In first Roman, what to understand is nothing but in first Roman, we have carboxylic acid is there. The carboxylic acid COH lost its preference, and the first one as it is linked with the unsaturated carbon directly. Second one, if you observe, second one, yes, we have carboxylic acid group is there adjacent to the ketone functional group in the cyclohexane ring. So in such case, what will happen means after heating only carbon dioxide will lose, will get this one. So it means preferential loss of this one is the second one. Whereas third one is there, it is very difficult. It does not lose its carboxylic acid groups, very difficult to remove. So it means first one and second one, first one and second one are the order of the loss of a functional group in a preference. That is first comma 2. First Roman 1 comma Roman 2. So option A is the right option for this one. Whereas 8th question, which of the following is an electrophilic reagent? Which of the following is electrophilic reagent? You see 4 options we have. A is water, B is NH3, C is OH minus, and D is NO2 plus. C is NO2 plus. On seeing this one, you come to know that NO2 plus is there, electron deficient species, definitely it acts as electrophile. So what is the answer is option D is the right answer for this question. Okay. Let us move to the next question. Which of the following compounds will show highest dipole moment? See, 4 type of the structures are there in our Roman number 1, 2, 3, 4 are there. Ketone functional groups are there, and internally double bonds are also there. Unsaturated ketones, diketones also given in this. That means quinol. Okay, benzoquinone also given. Now you observe in this 4 we have one thing is very clear. Highest dipole moment is shown when the highest what we call that bond struggle, means bond strain is there in the first one. We have more because of that one we can understand that dipole moment is more for the first case. Oxygen is present, obviously it is more electronegative, dipole moment is possible. Whereas in the others, means second Roman, third Roman, fourth Roman, if you observe, this is a kind of symmetry is developing in others. Whereas cyclopropanenyl, whatever propane type of ring is there, that ring is having double bonds or not, that will have lot of strain, exhibits highest dipole moment. A is the answer. Next question, pure 2-butanol has a specific rotation of plus 13.5 degrees Celsius. 13.5 degrees is there. A sample of 2-butanol prepared in the laboratory and purified by distillation has a specific rotation minus 6.76. What is the composition of the mixture? Whenever they ask the question like this, composition of the mixture points and all, here one thing is very clear about this. A chiral compound is there, usually chiral compound prepared in the laboratory. Resin mixture is there. In these cases and all, since 25% of the racemization has zero contribution towards specific rotation. So what we understand is here 25% is having a racemization. Therefore, observed optical rotation is due to 50% inversion, 50% of this 2-butanol is there with specific rotation minus 13.52 is degrees is there. So we have a formula for this one. I'll show you that 1 minute. Yeah, what is the formula is nothing but alpha experimental or observed, that is 50 by 100. Estimation means 50% of this 13.52 degrees what they have given in that. So 50% of this one is minus 6.76 degrees. Okay. So such cases and all developed means you can understand one thing that in this question whatever they mentioned 50% is 2-butanol and remaining 25% is racemic mixture. So pure form of plus 2-butanol has specific rotation plus 13.52 means it is minus 6.76 is 25%. So 25% is nothing but racemic mixture and remaining 50% is that 2-butanol minus 2-butanol is the answer. That is the composition. Next, 11th one. A sample of 50 degrees of an 50 grams of an organic compound was treated according to Geldal method. The ammonia evolved was observed in 50 ml of 0.5 molarity H2S4. The residual acid required 60 ml of 0.5 molarity solution of NaOH for neutralization. What will be the percentage composition of nitrogen in the compound? So whenever this type of Geldal method things and all you are preparing, for that we have a formula is there to find the percentage of nitrogen in Geldal method. That is the percentage of nitrogen is equals to 1.4 into that molarity of acid. Actually, if you take normality, it will come perfectly. Molarity given the question also can convert into normality. That is normality of the acid into volume of acid divided by the weight of the organic compound. Weight of the organic compound. In this 1.4 into normality of the acid is 0.5 H2SO4, normality is 1 into what is the volume of acid. So whenever you are finding the volume of acid from this question, so once you observe what is the exact volume of sulfuric acid given 50 ml, 0.5 is the H2SO4. What is the number of equivalent is 50 and residual acid the number of equivalents is 30. So 50 minus 30 is actual point of discussion, that is volume of acid. That means 50 minus 30. How 30 came? 60 into 0.5, 30 equivalents divided by weight of organic compound is 0.5 given. That means it is 1.4 into 20 divided by 0.5. So 20 by 0.5 is 40. So you can write 40 into 1.4, that is 56. So 56% is the answer for percentage of the nitrogen in the given organic compound composition from Geldal's method. So 56 is the right answer for this question. They have asked from some basic concepts and principles. Next question. Question number 12, if you observe, which among the given molecules can can exhibit tautomerism. So if you see the Roman 3, Roman 1, 2, 3 and all, in this, what you have understand is nothing but there is some bridged oxygen is also present. Usually because of bridged oxygen, the tautomerism is quite difficult. And whereas the other cases are, the second one if you observe, there we don't have any kind of alpha hydrogen. And third one, yes, it is possible we have alpha hydrogens. Due to that one, we can say the third Raman can exhibit the tautomerism. Okay. Once again, I'll show you what is the third one structure. Third one is given to us is like this. Internally, one bridged carbon is also there. And we have a double bond is present like this. It means you can have the alpha hydrogens here in this position. Because of that, automatically you can write the tautomeric structure of this compound. Okay. Tautomeric structure of this compound you can definitely write by shifting that double bond like this. So this is possible. So that's why what is the correct answer for this one is Roman number 3. Next. Lassane's test is not shown by disonium salts. What is the reason behind that one? So one point is very clear that Lassane's test is used to detect the extra element like nitrogen. So nitrogen gas on heating much before the reaction with sodium. So Lassane's test is not shown by disonium salts as they form nitrogen gas upon heating, which the much before the reaction with sodium. So that's the reason why disonium salts are not giving the Lassane's test. Whereas the first option, if you observe form NH3 gas, no, it won't give NH3 gas. Disonium salts upon heating, they will give nitrogen gas. That is the reason they are not responding to Lassane's test. Second option is right option. 14th question. If you see the 14th question, which of the following are correct for the addition of halogen to alkane? So when you are adding halogen to alkane, what is the exact statement is correct? So whenever you add, one point is very clear that I will show it to you. That an alkene if you take like a double bond alkene if you take like this, if you're adding halogen, usually halogen like X2 is there, or chlorine if you take chlorine, Cl2, one is plus, one is minus like this. This is actually happening in the electrophilic addition reactions. So when the electrophile come onto this one, what will happen? There will be a cyclic compound formation, and a cyclic halonium ion is going to be formed. Cyclic halonium ion is going to be formed here. This is plus like this. The double bond is going to be eradicated in this one like this. So this type of possibilities are there. That is why we are saying that this compound, whatever compound is there, that reaction involves cyclic halonium ion as an intermediate. So 14th question, this question, we have first option is the right option. Second one, why it is not important? Reaction involves carbocation intermediate. No. Addition of syn addition reaction. No. Symmetrical cis alkene gives meso product. No. Question number 15. Question number 15 we observe. Two pure organic solid samples were found to have nearly the same melting point. The melting point of 1:1 mixture of two was found to be lower by about 15 degrees Celsius. It means that the two samples contains dash. Carefully observe organic compounds having samples found to have nearly same melting point. And melting point for 1:1 mixture of these two compounds found to be lower, about 15 degrees. What is the meaning of this one? It's nothing but the compounds are different. Definitely they have that type of difference is going to come in the melting point difference. Then different compounds are having a yes mixed of the melting points is depressed if the two solid organic compounds are different. So different compounds are the answer for this question. 16th question, if you observe carefully, hydrolysis of carbon chlorine bond produces. Hydrolysis of carbon chlorine bond produces. Any hydrolysis one produces one cation and one anion. So C option is the right option for this question. Next, 17th question. Which of the following compounds will be suitable for Geldar's method of nitrogen estimation? So already we observed that some of the compounds which are not responding to Lesson's test, as the compounds may be diazonium compounds, or the compounds may be any kind of ring structures compounds are present. In this, very convenient method actually we have is the nitrogen linked to carbon and hydrogen. Nitrogen linked to carbon hydrogen, not used for nitro compounds, azo compounds, azoxy compounds. So nitro compounds means NO2 compounds, azo compounds mean diazonium salts, and also at the same time this nitrogen is present in the ring. That means compound contain nitrogen in the ring we have, for them also it is not applicable. So for which one is applicable means second one, that is aniline. Once we will see that, observe this one, we have a ring is there, first one, that is actually pyridine ring. Internally there are some double bonds are present, nitrogen is present in this, it cannot come out, it will be cannot be easily estimated using Geldal method. Whereas nitro compounds are there, nitro compounds are further subjected to a kind of reactions where nitrogen is very difficult to remove from this carbon and carbon to the of the benzene ring. Where diazonium salts are there, upon heating they are giving nitrogen. So that nitrogen gas, whatever they are giving, which is also not treated properly, which is not giving proper result in the Geldal's method. So these three, excluding these three, if they have given the aniline, yes, nitrogen compound aniline, that is only possible in the estimation of Geldal method. So the very convenient method for estimation of nitrogen organic compounds is Geldal method, applicable only for a few compounds, and some compounds it is exception. So second option is the right option for this one. Question number 18. If you see question number 18, which of the following compounds the carbon marked with asterisk is expected to have greatest positive charge? So positive charge is greatest means carbon chain we have BrCl, CH3, MgCl are present. Chlorine is having higher electronegativity, negative inductive effect is possible. So that will pulls the electrons, takes the electrons from the carbon chain. Greater positive charge is possible. In the case of second option, we have that is chloro compound. Next, 19th question. Dichlorocarbon is generated by the action of potassium tertiary botoxide on chloroform. This is an example. What is this? This is usually whenever they are given like this potassium botoxide and chloroform, dichlorocarbon is generated. Actually, this is called alpha elimination reaction, in which both hydrogen and chlorine are lost from the same carbon. So, tertiary botoxide and chloroform, these two, if you observe, dichlorocarbon is generated from this. I'll show you. What is dichlorocarbon is nothing but that is CCl2. This is generated. So this is generated due to the action of potassium tertiary botoxide. What is potassium tertiary botoxide? Means CH3 thrice C OK, like this. This is minus, this is plus, and this is treated with the chloroform formula CHCl3. So in this, what is going to happen is the potassium takes away one chlorine and forms KCl, and remaining thing is nothing but alcohol, tertiary butyl alcohol, CH3 thrice COK, and rest part of that one is CCl2 dichlorocarbon. So this you will call it as alpha elimination. This you will call it as alpha elimination, because straight away this carbon is linked with hydrogen. So that hydrogen we are removing. That's called alpha elimination reaction. So alpha elimination is happening. Both the hydrogen and chlorine are lost from the same carbon. That's the answer. So what is the right option for this one? Is first option is the right option for this. And let's see the next question. The decreasing order of stability of the following alkanes. We have 3-4 types of alkanes they have produced. In this simple trick is nothing but double bond attached carbon must have more number of alkyl groups. Here in the options we have methyl groups are there, which is having more methyl groups. That is the highest stability we have in this one. According to that one, fourth Roman, if you observe, double bond carbons are having methyl groups. That is the highest stable compound. So that is matches with our second option. So second option is the right option. B option is the right option for this question. What is the meaning of this one is higher the number of alpha hydrogens, more is the hyperconjugated structures, more is the stability of the compound. Due to hyperconjugation only, we are selecting the fourth one is the highly stable one. Then after we have third one, then after we have second one, after that first one. Okay. Next, question number 21. Correct match between items of list 1 and list 2 is, we have list 1 and list 2 are there. In this list 1, we have colored impurity and mixture of orthonitrophenol and paranitrophenol, crude naphtha, mixture of glycol and sugars they mentioned. In the list 2, we have steam distillation, fractional distillation, charcoal treatment, distillation under reduced pressure out there. So if you just carefully observe this one, from this what we understand is nothing but yes, we have colored impurity can be easily removed by using charcoal treatment. So A is R. And when it comes to this whatever orthonitrophenol, paranitrophenol, actually they have hydrogen bondings are there. So that hydrogen bonding can be easily identified. That means purified the compounds using fractional distillation. So yes, 1 minute. Yes, steam distillation. So where can be understood by steam distillation. Steam distillation is answer BP. Crude naphtha is there. Crude naphtha can be distilled using fractional distillation, and mixture of glycerol and sugars that can be purified using a distillation under reduced pressure. So crude naphtha is linked with, is related to fractional distillation CQ. So AR, BP, CQ, DS. Second option is the right option for this question. Next, 22nd question. See 22nd question. Which of the following correctly shows the order of decreasing percentage of nitrogen by mass present in the following compounds? If you calculate the percentage by mass of these nitrogen compounds, we have the calculation is telling that a total calculation by mass percentages, nitrogen in C3H9 C3H9N3 is having highest percentage by mass compared to C3H8N2 and C6H12N4. So C option is going to coming as the right option for this one. For that instance, once I'll show you what is that percentage by mass calculation for this one. What is one formula we have selected is C3 H9 N3. So C3 H9 N3, if you take in this 3 carbons is 36 plus 9 is 45. 45 plus 1 nitrogen is 14. So 42. 45 plus 42 is 7, 87. So it is 42 by 87 into 100. That's the percentage. Whereas C2 H8, C2 H8 N2 is one more is there. In this case, what will happen? 2 carbons is 24 plus 8 hydrogens, 32 plus 2 nitrogens is 28. So 32 plus 28 is 60. So 28 by 60 into 100. Another one we have C6H12N4 is there. C6H12N4 is there. 4 nitrogens, 1 nitrogen is 14, 4 nitrogens. 4 nitrogens. What is 4 nitrogens value? Okay, what is that? 156. 4 4s are 56. So this is 56. Now 6 carbons is 72, 72, 72 and 12. So if you just add 6 plus 4, 10, it is 1, 6, 13, 140, 140 came. So 140 is the mass. In that, nitrogen is how much is 56, 56 into 100. So in this, 42 by 87 is the big value. After that, 28 by 16 to 100 is big value. Next, we have 56 by 140 is big value. So accordingly, that the percentage is there. So that one is matches with our third option in this one. Next, 23rd question. See, the correct statement regarding the electrophile is, what is the correct statement regarding the electrophile is? Electrophile is negatively charged, wrong. Electrophile generally neutral species can form bond by accepting pair of electrons from a nucleophile. Usually, electrons are neutral species can form a bond by accepting a pair of electrons from nucleophile. That is a suspicious one. So it is not necessary every time. Whereas the third one, if you observe, electrophile can either neutral or positive. So when they say neutral means what about positive? That's why second option is also not correct. Third option, yes, they may be neutral. They may be positively charged, can form bond by accepting pair of electrons from nucleophile. Bond will be formed, but the species nature is neutral, positive, both not given in the A, B. So C is the right one compared to the A and B. So C is correct. What about D? Electrophile is negatively charged species. No, that is completely wrong. So C is the right option for this question. Next, 24. Like we discussed in the previous questions also, the same thing. Bridged oxygen is there. Highly unstable one. Whenever oxygen is present in the bridged one, bridged carbon, that means bridged head of the carbon, then that is highly unstable. So first one is highly unstable among this. So the question is, among these compounds, which are the following is the correct order of percent enol content. Percent enol content means tautomerizing content is more, percentage of enol, in which one is more they have asked. In such a case, we can understand that NO2 is present due to that delocalization is possible. So third one, second one, first one. Second option is going to be the right option. If you just carefully observe the structure, that enol stabilized by hydrogen bonding in the case of the third one. That is also one reason we have. So second option is the right option for this question. Next, last question in this video. The ammonia evolved from the treatment of 0.5 grams of organic compound estimation of nitrogen was passed in 100 ml of 0.1 sulfuric acid. The excess of acid is required 20 ml of 0.5 sodium hydroxide. Okay, complete neutralization. The organic compound is, carefully observe. If you do the calculation percentages, then after finding the percentage, you have to verify the percentage of nitrogen in this options given to you. So let us do calculation first. So a percentage composition and all, if we just do, we have the percentage of nitrogen. Percentage of nitrogen calculations and all, if you observe, that is 1.4 into Okay, 1.4 into normality of acid into volume of acid divided by weight of organic compound. So we have 1.4 into what is the normality of acid is yeah, acid 100 ml given, normality is 0.1 sulfuric acid. So that is 0.2 is the normality. Normality is 0.2. What about the acid case? Sodium hydroxide and all. See, 100 ml is there. 100 ml into 0.2 is that is yeah, 20 equivalents of acid, whereas 20 ml of the sodium hydroxide given. Sodium hydroxide is 20 into 0.5, that is 10 equivalents will come. What is the difference is here? Difference is 10 equivalents. So this is what we have understand, that this is 10 divided by weight of organic compound given is 0.3. So if you just do that calculation, this is 2.8 by 0.3. I'll let you know. You will get this calculation equals to 46.6%. I'll check it. Ten by 1000. So 20 by 1000, 10 by 1000 is finally 10 by 1000, means 1 by 100. So equivalents of nitrogen is 1 by 100, 10 power minus 2. Now what is the percentage of nitrogen? Is nothing but, yes, 1 by 100 into 14 by 0.3 into 100. Equivalents we have calculated ammonia. So then it is coming 46.6%. So what is 46.6%? But yes, after knowing that number, we come to know that urea nitrogen percentage is 46.6%. The compound is urea. So urea is the right answer for this question. So ammonia evolved. If they are given the question ammonia evolved, you can use that Jumas method as the correct method for the estimation of this. So whether it is any of the purification techniques asked, you can use that technique or mathematical formula you can apply and get that percentage of nitrogen. That's all. So these are the things, dear students, we have discussed in this video. So make sure that you have anything is there, and this mathematical formula for the purification of percentage of nitrogen and all, you can use to find that percentages, and after that verifying that whatever the suitable nitrogen compounds. Thank you very much. We'll see in the next video. Until have a nice day. Thank you.